Hello guys, welcome back to Chemistry Exams Prep. This is Dr. Kulbhushan. I am back with another interesting question. This question is asked by Mr. Qasim Suleiman from Kast, Saudi Arabia. In this question, we need to find out the order of solubilities of these following four compounds in water. So we know that water is a very polar solvent. It has a nice big dipole because the difference in electronegativity between oxygen atom and hydrogen atom is too great. So it generates a big dipole, and the magnitude of dipole is towards the oxygen. So now water has a very high dielectric constant, and it's a universal solvent, so it dissolves a lot of different solutes. Water is the solvent for all biological processes, the biochemistry reactions. So here we need to think about the intermolecular forces in order to answer this question. So let's have a look on what type of solutes or what type of species are given for the solubility. So first one is the sodium phenoxide. This is an ionic species. The second one is phenol. This can hydrogen bond, and hydrogen bond, as in water, is the manifestation of having a very large dipole. So compound third is chlorobenzene. So it does not have any ions or hydrogen bonding capability. All it has is a dipole, because the difference between electronegativity of chlorine and carbon is high. So chlorine gets a partial negative charge and carbon gets a partial positive charge. So it's got a nice permanent dipole. The third one is benzene. So benzene is a nonpolar molecule. So this one has dipoles, the chlorobenzene, and benzene is a nonpolar hydrocarbon. So now we need to see the interactions between all of these compounds with water one by one. So let's have a look on A. So A is ionic. So the type of interaction that would form with the water would be ion dipole interactions. So water has the dipole, and there is an ion in the phenoxide ion. Oxygen has a negative charge. So this is the interaction that is the most important for this species. Now second, phenol has a OH functional group, and this bond OH, being very polar, it can hydrogen bond. So this oxygen can hydrogen bond with the hydrogen of water, and this hydrogen of phenol can hydrogen bond with the oxygen of water. So these are the interactions that would occur in case of species B. Therefore, this would show the interactions of hydrogen bonding, means dipole interactions. but this dipole-dipole interaction is stronger, so it's called the hydrogen bonding. Whenever hydrogen is attached to a very electronegative atom, in case of oxygen, like this oxygen hydrogen bond, or nitrogen hydrogen bond, or fluorine hydrogen bond, if this is the case, then due to large difference in electronegativities, there is a bigger dipole, and that results in hydrogen bonding. So the third one, the interactions are dipole-dipole interactions as well. Dipole-dipole interactions, and the interactions are from Cl, that is negatively charged dipole, to hydrogen of water. Now the third and the last species, it's nonpolar, so it would not have a permanent dipole. So this one would have London dispersion forces, or they are also called van der Waals forces of attraction. So this will have a temporary dipole, so there will be interactions of those temporary dipole with the permanent dipoles of water. So this is how you could show it. There could be water has a permanent dipole, but the hydrocarbon, it does not have a permanent dipole. However, when this oxygen of water is around, so this bond gets polarizable, and once this bond is polarized, there are generation of temporary dipoles, and that's the result of having these non-polar temporary dipole and permanent dipole of water's interactions. Now let's have a look on our choices here. So the first choice is that the B is more soluble than C, and C is more soluble than A and D. We notice that B is less soluble than A because these are ion dipole interactions are the strongest. Therefore, and these London dispersion forces in case of D are the weakest interactions. So basically the strongest interactions with water would be ion dipole, which is A, and the second strongest would be hydrogen bonding with water, that is B. Third is the dipole interactions with water, that is C. And the last one would be the nonpolar temporary dipole interactions with water. So it seems that this A is not correct because B does not have higher solubility than A or C. So the choice A is incorrect. Now for choice B is more soluble than C, and C is more soluble than B. So in this order it seems like a better choice, but there is a problem that it has C before B, so that choice is not correct either. Choice C is B is more soluble than A is more soluble than C, and C is more soluble than D. So there is a problem here again, the same thing, the solubility of A is highest, so that's not the right choice. So our right choice is D, where it shows that solubility of A, which is ion, is higher than the hydrogen bonding compound B, and B hydrogen bonding compound is more soluble than just having dipoles. C, chlorobenzene, and finally all of these interactions are stronger, so D is the least soluble in water. So benzene is non-polar. It would not be soluble in polar solvents like water or alcohols. It would rather be soluble in non-polar solvents like hexane, toluene, etc. So now, is there any trick that we can apply here in order to get to the correct answer? And the answer is that we should know something. We can't just wild guess here. However, if you can just only see that ions are more soluble in water, then you can reach to the conclusion and you can eliminate some choices here. So for example, you can eliminate choice A here because we know that ions are the most soluble. Same way, we know that the hydrogen bondings are more soluble than just dipoles, so you can remove choice B. And about choice C, again the same principle applies as we did for the A. So A is ions are the most soluble in water, so we can eliminate choice C. And come to the conclusion that the correct answer is D. So there are some small tricks that you can apply, but the fact remains that you got to have a basic understanding of how chemistry works, the general organic chemistry principles, and then you can answer many questions based on these principles. So we'll stop for this question here, but if you have any questions, please let me know and I would be happy to include them in our next video. Thanks for watching.